it's live. It's alive. All right. Okay. Dun dun dun. Yeah. Is there no? I think there's a halfway if you just do it like a little bit more. Perfect. Okay. So. All right. So I just realized like we don't have a way to get this link to you quickly either.
I can put it on the YouTube channel.
But I don't know that they have a way to get to the YouTube. Oh, you sent the YouTube channel out. Okay. Okay. Instructional materials for today's Docker workshop. Okay, so I am going to be working off of this, and I don't quite know how to get the URL to you most conveniently. You know what I'll do? I'll just write it down on the whiteboard, because clearly in this age of digital communication, whiteboards are the most effective. But it's okay. So if you go to github.com/NGS docs, and then it should be 2017-DSI-Docker -May, which hopefully all makes sense as to what those words should be, except for the NGS and the docs. Okay. And I just tweeted it. My handle on Twitter is Titus Brown. So go to twitter.com/CTitusBrown. It's there, and then it's also on the YouTube channel momentarily. Okay, cool. So hello everybody. I'm Titus. I'm a professor over in the School of Vet Med here, and I'm a computational biologist, bioinformatician, genomics, something. We do a lot of computational work in my lab. I should say on the second from last, on the far right from where I'm standing, is Luis, who's a graduate student in the lab, who does a lot of that computational stuff. So Duncan kindly invited me to talk about Docker. I think that was your idea, Duncan. Anyway, it was a shared idea, so I have a confession up front to make, which is that I do not use Docker on a daily basis. I don't use Docker on a daily basis for the reason that I just spoke with Danielle about, which is that none of the compute clusters that we use, none of the high-performance compute clusters that we use support it. And we'll talk about that at the end. But right now, as far as I know, you can't use Docker or its companion companion application Singularity, which does run on clusters, on any of the UC Davis campus clusters yet. But you can use it on a variety of cloud machines, including Amazon and Exceed Jetstream, which is where I have some machines running right now. And you can use it on your laptop, where it's already quite useful if you can get it all installed and running. So why, given that I don't use it, why am I up here talking about it? We're very interested in using it. We're planning to use it more, and I think it's something that will become fairly standard. The general container approach, which we'll talk about in a sec, will become fairly standard in science in the next 5 to 10 years. And at the end, I'll tell you some of the stuff we're planning to do with workflow. We're thinking about doing with workflows and packaging our software and other people's software for ourselves and others to use as well. So this is going to be only about an hour. I have probably about an hour to an hour and a half of materials on here with some links in it. This page will stay up arbitrarily long, much longer than, I won't fix it. So if it gets out of date, it'll get out of date. But the page that I'm presenting from will stay up indefinitely. I didn't get my act together enough to have you all install this stuff in advance. But if you've had a chance, if you have Docker installed, or you get a chance to run these commands on Mac OS 10 or on Windows, not these commands, if you get a chance to install these things on Mac OS 10 or Windows, it doesn't take that long, and it will let you run everything we're going to do today on your own laptop. You'll need about 4 gigs of RAM and about 20 gigabytes of free disk space. That's an overestimate. You'll probably need far less than that, but that's roughly, if you have that much, you're home free. And if you can't install it, please send me an email saying something like Docker tutorial cannot install, and I'll give you a machine in short order that I'll give some of you, a select few of you, a running machine that can run this stuff. Okay, if you have Docker installed, please run these 3 commands at the command line as well. I wouldn't suggest typing them in from this page. I would suggest finding the page and then copying and pasting them. What these will do is start a download of a couple 100 megabytes of stuff that would be more awkward if we were all to do it at the same time. So it's better to do it now. All right, so, well, actually, the first thing we're going to do is actually run one of them. So I'm going to run this, and those of you that can follow along, and those of you that can't, we'll take a break after I run it and show you what's going on to send the machines out so that some others of you can try this. That makes sense. I prefer to just show people first and then come back and explain what's going on. So what I'm going to do is I'm just going to run this command. This is docker run. There's some gobbledygook, and then rocker/tidyverse. And rocker/tidyverse is the name of a suite of tools that includes RStudio Web and a few other R tools already prepackaged in a Docker container. I should say that I do not have most of the tools in Rocker Tidyverse installed on my laptop. What I have instead is this Docker image that contains them. So essentially, I'm installing a prepackaged version of all of these tools and then running it with Docker. So I'm going to run that at the command line. Can people sort of see that in the back? All right, cool. I'm going to run it, and if I hadn't downloaded it already, it would be saying, "Oh, I don't have this image locally, so I'm going to go grab it remotely and pull it down," and that might take, I think it took like 2 minutes over my home internet connection. And here, with everybody in the room doing it, it might take between 1 and 5 minutes, depending on the internet gods. So all of the stuff that's being output is being output by software that's installed on that Docker image. And I'm going to ignore that output for a moment because it's all stuff that has to do with running the programs and nothing particular to do with Docker. And I'm going to go to the web page localhost:9001. This is actually in the, if you look at the paragraph, next paragraph, you can connect to it on your laptop, go to localhost 9001. Those of you that are randomly good at pattern recognition will know that there's a 9001 here. That 9001 is the 9001 that we're using on in the web browser. Okay. And when I go to this localhost 9001, it directs me to sign into RStudio. How many of you have used R or RStudio? Pretty much everybody. Okay, good. So this is RStudio Web, which is a web-based version of RStudio, as you might guess, and it has many. I assume most of the features of the RStudio that you would download and run locally on your laptop. If you are here, you can log in using RStudio and RStudio is the password, and you sign in, and you get a web page. This is running in my Chrome browser. You get a web page that looks and feels like R because it is in fact R, and it's running inside of a window that looks an awful lot like RStudio because it basically is RStudio. Just to demonstrate, even though I don't program in R, just to demonstrate that it actually is R, if I paste all of, I think this will work, right? Yeah. If I run some R code, I can get an R plot, and life is good, right? So I'm running all of this stuff on my laptop inside this Docker container. Okay. So people sort of seen this thing before with Docker? Yes, no, don't worry about it. We'll go over it. We'll go over it in a second. So the thing to keep in mind about this is that this is actually a fairly large collection of packages. The tidyverse includes, I believe, ggplot and all of the all of Hadley Wickham's stuff. What he apparently doesn't like being called the Hadleyverse, but you know, dplyr and is it tidyr? I forget. Anyway, there's a bunch of different commands that a lot of R aficionados use, and this has all of that stuff installed. The other thing that might be interesting to note is that my machine is a Mac, and what I'm actually running is the Linux version of RStudio Web and all the packages compiled for Linux. And so what lets me do that is Docker. What I'm essentially doing is I'm running this, I'm running a small, effectively virtual machine, although it's not really, it's a lighter weight kind of virtual machine that is Linux running inside my Mac that lets me access that Linux box as if it were its own separate Linux box. How many of you have used the cloud for anything? Okay, so like Amazon Web Services, or okay, how about high performance compute clusters like Kubernetes or Farm? Okay, so imagine that I've spun up my own tiny little version of Kubernetes or Farm here, a single, you know, sitting within my laptop, or I've spun up an Amazon Web Services machine. It just happens to be spun up inside my laptop. So what Docker, let me go through a couple of the points I want to make. Okay, so we had to install the image, but you didn't have to install any software other than Docker. That might sound like a sort of, well, either way you had to install something. But once you have Docker installed, at least in theory, you never need to install another piece of software again, because you can just run stuff inside of Docker. So RStudio is already on this image. This is running on my laptop computer. That's both good and bad. It means that the resources on my computer, the memory, the disk, everything is whatever's available on my computer. So if I have a lousy laptop computer, I'm not magically making it cooler by running. In fact, it's probably the opposite. Docker consumes some resources, so it's sort of a net loss probably. This is running in a completely isolated sandbox. So something that I don't actually know how to do. Can anybody guide me through saving this as a figure? As a PDF file? No? Nobody knows how to write PDF files?
It's PDF and then file equals, oh, you need quotes, double quotes. File equals, and then your file name. PDF, sure. And then you need to.
Do I need to do dev.auth or something?
Oh, wait, no,
then I need to rerun all of this. And then I do dev.auth. Okay, great. So, so now I have this DSI.pdf. Now, the problem with the fact that we're running in a sandbox situation is that this DSI.pdf exists only within this running Docker container. And there is no simple, it doesn't exist on my hard disk on my laptop in a normal way. There are ways for me to get at it, but it isn't automatically, this RStudio Web isn't automatically connected to the file system on my Mac. That could be a good thing. Imagine you're running software that generates a lot of temporary files or relies on a lot of little files that you don't want cluttering up your computer. And it can be a bad thing as when I have a figure that I desperately want to recover, but that I have to figure out how to get. Okay? This isn't a situation where you can do an SSH connection in. This isn't a machine that's running an SSH server. You have other ways of getting at it. So it's yet another, I don't know how many of you have been through this in the last, in my case, 30 odd years. Yeah, 30 odd years. But it seems like every 5 or 10 years, there's a whole new method of accessing remote disks and file systems and stuff in Unix. This is yet another fun opportunity for learning. And I'll show you how to connect this. When you're running the stuff on your laptop, you can connect this disk directly to a directory on your laptop, and we'll show you that. I'll show you that in a second. But not when you're running on a cluster. When you're running on a cluster, you have to connect it to the clusters or the remote computer's disk. So there's no magical connection between where you're running the Docker command and where the Docker machine is running. Okay, some details. For example, the username and the password. And if you look at this run command up here, there's this 8787. Those details are set by the people that build the Docker image. And I'll show you how you build a Docker image in a moment. But the username and the password come pre-installed. The local port, and I can talk more about that if people are interested, but the local port that RStudio Web is running on in its little container, that's configured by the people that built the tidyverse container. Those are chosen by other people. Other details, this port 9000 that we're using here, this port 9000 that we're using, that's set by us. And so you need to know, so when you run these things, you need to take care of situations like, how am I going to refer to the container and to the Docker container? And what disks do I want to connect? And then what does the container want me to connect my 9001 port to, and what does the container write data to? So you can change some things, but not all things, basically. So how many of you are actually running this command? Any of you? Okay, so a couple. Okay, so hit Control-C twice. And now, if you've done that, the Docker container dies. It's okay. It's a pleasant death. And without a little bit even more trouble, you can no longer access the files on it. They're still there. They're in an image that you can access, and I can show you how to access. But basically, you should think of them as having gone away. Yeah.
So if they're in that image and they can't be accessed, do you risk, if you're using Docker a lot, just basically filling up your entire hard drive with things you can't access? Like, if
yes.
Still there. Okay.
Yeah, and something that I've omitted from today's tutorial are the cleanup commands that let you get rid of all that stuff. We have a very sensitive HDMI connection, or anyway. So yeah, so what happens is, and I'm just going to talk about this rather than demonstrating. Let me just see if I can figure this out. Okay, my laptop has clearly seen something. Okay, so this seems like maybe a projector issue. It's okay. Let me just see what. Oh, this. Yeah. Maybe it's on like the VGA channel now or something. Nope. There we are. Okay. So so don't follow along with what I'm doing now. I'll just answer your question. If you go back to Docker, if you go back to your command line and you run docker ps-a, you'll see all of the different things that you ran, and in this case, it's actually going to be, how do I, my terminal's a little messed up because I'm, okay. So what you can see is there's this, because of the, am I still screen sharing, by the way? No, I'm not still screen sharing. Okay, let me fix that. So I'm going to decrease my font size a little bit, maybe if I can, to get the screen size. Okay, so if you do docker ps-a, you will get all of the containers that either are running or are no longer running. And in this case, we have one that's no longer running because we hit Control-C twice and it went to bed. And it was the rocker tidyverse one. And there's this container ID. And I believe you can do docker cp, the container ID, / home rstudio dsi.pdf to dsi.pdf. And it will copy it locally. So you can still access the things. You can actually start the container up again. You have access to the file system. It's just in terms of convenience, it's more or less gone away. So for people that do a lot of work on their laptop, I think the way that they tend to work, and this, I should say, this container, this image was built by a guy named Carl Bediger, among others, who uses Docker to run all of his RStudio stuff. Because that way he doesn't break one set of R package installs with another set of R package installs. I believe what he does is he basically points the home directory at a local directory on a project-specific directory on his laptop, which I'll show you how to do in a second. And then all of the other files can basically be lost because they're all temporary files he doesn't care about. That makes sense. Another way of doing it, and this is probably too much, but I'm just going to mention it, is you could have a GitHub or a version control repository that you clone to your Docker container, make modifications, commit, push, and then kill the Docker container, right? Which is a safer way of working, but also is like adds some friction. And every now and then you'll make a mistake and be like, hey, where'd all that work go? Which seems like a suboptimal situation to be in. But yeah. Okay. So so just to sort of show you what's going on. So I have a very high-tech CAD program that I use for making my figures. So all the figures are artisanal. This is Northern California, so handcrafted artisanals in. And essentially what we're doing is the yellow, the orange line is my laptop. We have the Docker machine client, which is that Docker command. And my machine's connected to, has disk and network. And then the Docker machine client is running one or more containers. So we haven't run more than one container yet, but there's no problem with running multiple containers, assuming you have the computational wherewithal. And then we've managed to connect to the network and the disk because it's all running within the same orange sandbox, which is or the same orange box, which is my laptop. We've managed to connect both the network and the disk directly to the containers. This is a specific case of the general case, which is where Docker is running on the same machine as the client. The general case is you have a Docker machine client running somewhere, and then you have one or more Docker hosts, which are either local or remote machines in orange, and each of those machines has some local network and some local disk, and they're running one or more containers. And you're controlling the remote containers from your Docker, from your Docker client. So you can get into extremely weird situations here where like I'm using my laptop to log into an Amazon Web Services machine that's then connected to another Amazon Web Services machine that's much bigger, that's running my actual Docker containers. And then, maybe, so it can sort of be virtual machines all the way down. But the basic structure is you have something that's issuing the commands to one or more orange boxes that are running the Docker infrastructure. And then within that Docker infrastructure, you have one or more containers running on each host. So the size, in particular, this could be something that's like your phone or your iPad, because issuing these commands is just a matter of configuration. And the orange machine could be something that's much larger. That's a much bigger machine that you're spinning up as you need it or as you allocate it. Something else that I'm not going to talk about at all today, because I don't know anything about it, is there are systems like Kubernetes that Google, for example, uses, where you build multiple orange machines and have multiple containers and just say like, hey, here's all the things I want to run, make it happen. And that's something that is sort of probably not so useful for most of the people that I know in academia, because we generally only want to run a couple and we can manage that ourselves. But there are, if you end up in a situation where you want to manage 100 Docker containers, there are approaches for dealing with that. I know there are companies that run hundreds of thousands of Docker containers on a regular basis. Okay, so right. Let me do one more thing before I give people cloud machines. Let's do this. Run this command. So this is an adjusted version of the previous command. Docker run, some gobbledygook, -p. This time we put 9002 on our local machine connected to 8787 on the container. And then we have this -v command. What this -v command says is connect whatever my current working directory is to home RStudio on the running container.
Reload the page. There is a typo in the name of the container.
Oh, did you fix it? Thank you. Really? I thought I ran the, okay, well, anyway. Usually I'm better than that, sorry. It should be rocker/tidyverse, not rockerb/tidyverse. Okay, and so what this is going to do, so first let me remove my DSI.pdf and then run this command. What this is going to do is connect localhost 9002 now to RStudio Web. I have to log in again, I believe, although I might have already logged in once, so you might remember that. Yeah. And now the directory that I'm working in is magically connected underneath the hood by Docker to my current working directory and on my laptop. So now if I do the, if I run this R code, okay, I have to remember, what do I do? I say pdf DSI2.pdf, then I paste that code, then I do dev.auth. Does it have to be double quotes? No, it works with single quotes. And now you see DSI2.pdf is over here. And if I come back here, well, I'm going to kill this now with 2 Control-Cs. So if I come back here, there's also DSI2.pdf on my laptop. So this is what people who work on their laptop with these Docker with Docker tend to do, is they connect one or more directories on their local machine to. I probably shouldn't confuse people with this, but one interesting point for those who are considering using this to run workflows, to run multiple, big analysis workflows, is you can say, hey, I built my workflow image so that the data that you're operating on should be in /data, and the outputs should be in /outputs, and then you can connect whatever directory you want to /data, and whatever other directory you want to /outputs, and control which data sets it's looking at and where the outputs are going, solely by manipulating this without changing anything in the Docker container or what it's running. So it's sort of a way to say, there's a black box that's this image. If I run it as a container, it's expecting data, and it's going to produce output, and you can sort of control where that stuff goes. And that's indeed what a lot of the workflow stuff does under the hood, is manage that kind of thing. Okay. So I don't know if anybody sent me any emails, but
I have a question from online.
yeah.
I want to know how you use it. You logged in before.
Logged in before. So the question is, if you've logged in before, like on RStudio. So this is not a, this ends up, just to make everybody aware, this isn't a Docker question anymore. This becomes a web browser question, which is, if I've connected to if I've connected to RStudio server on port 9002, and I've logged in, RStudio Web has set a cookie in my browser containing my login information. And if I connect to the same RStudio web server with the same login information, it will recognize that cookie and let me log in. So it's just the browser more or less remembers. If I change the port, it won't work. If I do some other service, it's not going to work. It's just happens to be that when I was testing this, I ran it on port 9002, and so it magically worked. Okay. Any other? Yes.
How easy is it to search for like specific types of images?
Yeah, good question. So I use Google, and that works if the image is a big one. So tidyverse. So the 2 images that I have as demos for this are RStudio Web and Jupyter Notebook, which are used by tens to hundreds of thousands of people, and so they were easy to find. Generally, you're sort of going to be in 2 situations. Either it's going to be something a lot of people use, or a container is not going to exist. And the middle situation is, there's a small project and they've become enamored of Docker and they've made Docker images, and maybe they're up to date and maybe they're not up to date, but you can just ask them. So I would say, I mean, that's a sort of more complicated answer, but it's super easy to build them yourself too. So that's actually what I kind of recommend, is being a little bit of a control freak and being like, hey, you know what? I just want to use the version of the software that I know is the version of the software that I want to use. So I'm going to build my own Docker container, and it's going to be completely under my control. And that way, if it breaks, it's my fault. And if it doesn't break, it's also my fault, which is sometimes a better way to deal with the open source software world, if you've had that experience before. But it's super easy to build your own Docker containers, and then we'll go through that in a second. Any other questions at this point? Okay, who, if anybody, wants I have 4 remote cloud computers up for grabs. Does anybody want one? 1, 2? Okay, did you send me email? Okay, can you just, could you just put a check mark next to your email on this? They're gonna see it on the screen when I send it to you. But that way Danielle, do you need one, or? You just SSH into a machine, that's all. You just SSH into I'll just give you an IP address and a key.
Oh. This is pretty good where I don't have Docker.
Yes.
Never mind.
Oh, you're good, okay. So if you just want a Docker machine
Is it
to,
gonna be connecting to my computer?
no, you just have to be able to SSH out.
I'm just being careful.
You're fine for this.
Okay.
Okay, so I'll give out two. And this will just let you run all the commands and see what it's, get the visceral feeling of running the commands. All right, let me just go, so talk amongst yourselves. This is gonna take me 30 seconds to configure these machines. How many of you have used, are familiar with Exceed or Jetstream? No, nobody? Okay. So for those of you that are interested in playing with this, there's a, thank you. There's a service, an NSF-funded service that, hang on a sec. There's an NSF-funded service that will give you, whoops. How do I want to do this? Okay, this may take me an extra minute or two, but it's okay. So it's all under control. So it's an NSF-funded service that will give you free compute in effect for just filing an allocation proposal. It's called Exceed. They have a cloud computer-like setup called Jetstream that is very much like Amazon Web Services. You go there, you start a computer of a given size, and it consumes your allocation that you've gotten. And so we're happy. We have instructional materials on how to apply for an allocation and how to start up an instance and use it. So let me just figure out how to get this. Public key from an SSH private key. I didn't properly set this up in advance. Side note, SSH keygen -y. Okay. -y -f. So I have this sort of awkward thing. I set these up on my personal key, so I don't really want to give my private key for my laptop to Danielle, even though I like Danielle quite a bit. I just am concerned that she would then have access to everything. Okay, startup PM. I think I created one. We'll call it May Docker Bids, May Docker DSI. So we'll do search May Docker Bids, and that will go to May Docker.pub. I think I can send pub. I can't send private keys. Okay, I'm facing a little bit of a problem here, and then I don't know how much I want to. I'm going to stop the screen recording for a second. Sorry.
You like your back?
Sorry?
You your back.
That password would be hidden from you. I would not be posting a private key to a public IP address. Yeah. Okay, so let's see. CPA May Docker Bids. Okay, and okay, that's one, and you won't be able to log in yet. And I'll just send the other one. Tandu?
No, I think
Tandu?
Yeah.
Cool, okay. That's A-N-N at the end?
B-A-R-I-A-N-A.
Yeah, cool, okay. Great. One E, okay.
I'm saying this, is anyone else not signed yet?
And that's, which one was it? That's Docker 2 and Docker 3. Okay, so the username for both of you will be Titus, Titus, but with a private key that I send you an email. So let me just finish copying that over. If anybody's interested in learning about private and public keys for logging in without passwords, we're also happy to talk about that maybe some other time. May Docker to authorized cat. Docker to authorized keys. Okay, and I think I need to do one other thing, which is okay. Another thing here. Which one was this? This was Docker 3, Docker 2. Yeah, it's already all set up. For you? Yeah. Yes. CP. Okay, and I will set up a third just briefly, which is here. I'm a little worried that I may have sent, what did I even send, Danielle? Okay, and let me just set up that last machine. CP. I think that's it. We just need to send that to the last person. Is this Tun? Okay. Using the private key. Okay, we'll see if that all works for anybody. All right, so right. Have either of you been able to log in or even gotten the emails yet? Okay, well, let's just wait a couple minutes and then I can stop and check in again. So okay, so back to the Docker stuff. So I want to run a different program, not RStudio Web, but instead Jupyter Notebook. And so here, the format of this command might be becoming reminiscent. We do Docker run. We connect port 9000 to port 8888. You're like, how the heck did you know these numbers? And I'll explain that in a second. Again, we connect our current working directory to the directory /notebooks, not home RStudio. We run Jupyter /notebook and the command, and then we issue a command to the Docker container Jupyter-notebook. And what this does, once you have the command right, which hopefully I do, what this does, of course, is now run Jupyter Notebook. And the key thing is it runs it on port 9000, and it runs it connecting your current directory to the notebooks on the Jupyter Notebook server. So if I now go to localhost 9000, I don't know how many of you have seen Jupyter Notebook, but I get Jupyter Notebook running in that Docker container in the directory that I've been running these commands in. Yeah.
We might be going to cover this later, but I noticed everything that we've done for like all of our ports has that kite-matic.
Yeah, I don't remember where the kite-matic came from. I think it comes from running the Docker command, okay. But I'm not sure. It's kite-matic is like.
The way of the standard part, when you install that, you end up installing kite-matic.
Right, kite-matic is part of the Mac OS X install.
Okay.
So I've removed it without any problems, but yeah.
All right.
I should share my screen again. Sorry. Yes, thank you. Okay, so so there's a couple convenient things about Jupyter Notebook. How many of you have any experience at all with Jupyter Notebook? Have seen it? Oh, a fair number. Okay, so I'll do this. I'll just mention a few things. So this is a full Jupyter Notebook server. It comes with Python 2 and Python 3 installed as separate kernels. It also Jupyter Notebook also provides an upload and a download interface, so you can copy files to and from. So unlike the situation we were faced with our studio, now we can use this website as a way to upload files using the upload button. If we want to get a data file to our Docker or running Docker container, or we can actually click on the files and download them, although that doesn't work terribly well in the Jupyter Notebook. There's a text editor, so you can edit, like with our studio, you can edit the programs, not just in notebooks, but also separately. And then something that's sort of been surprisingly useful is there's a terminal. So this is now a shell prompt that is running in the Docker container through the web interface in my browser. And so I can now run shell commands, and instead of running them at my laptop level interface, I'm running them inside this Docker container, which can be handy in case you want to run stuff. I mean, you want to run stuff at the command line. This is one way to connect into the container and get shell access to it, which is sort of seems kind of roundabout, like we're doing an awful lot of different stuff and connecting in a lot of different ways. But it's handy if you just want to run a shell command. Okay, so right. So at this point, are there any questions about what I've shown you so far? It's totally ask whatever questions you want, and I'll tell you if I'm covering it later.
So this terminal we just ran, I do a lesson and it shows me my current working directory on my laptop.
Yes.
And not in the Docker image.
But it is also in the Docker image.
It is also
because when we ran it, we connected the current working directory to /notebooks.
Okay.
So if in the terminal you now run pwd, you'll see you're in the directory /notebooks, and this is the only directory on that container and all its subdirectories that's connected to your laptop. Everything else is isolated in the Docker container. So if you do cd ... you'll see something that looks very much unlike, well, you're running Linux, so it might look, I think, but it might look similar to what's on your laptop. But if you're on a Mac,
yeah, that's the Docker file system.
That's the Docker file system, yeah. And here's the fun thing. You can do whatever the heck you want on this, and it's not going to affect your laptop unless it's within your notebooks directory, right? So that's part of the sandboxing, is that malicious programs and accidental removals of the entire operating system don't affect your laptop, just hypothetically.
So then it's akin to having mounted my laptop in the Docker image.
Yes.
At this point, and then I can sort of transfer files back and forth.
Right. You can also do it, and this is something that depending on what you're doing, if you're one thing you can do is you can mount it read-only. You can modify that -v command so that your home directory or whatever other directories, like your raw data directory, you could mount your raw data directory read-only so that the Docker container cannot modify what's in your data directory. So all sorts of stuff like that. All right.
So you alluded to this, but I just wanted to clarify. So the two examples you're going through the red browser, but you can't just SSH straight into Docker.
You cannot SSH. You have to run. There's a Docker shell connection that you would run. So you would run Let me see if I can do it here. I'll show you. If I take off this, so this is the Jupyter Notebook command that I ran. If I put bash at the end, no, I need to do Jupyter/notebook, which is the container, the image name, and then I need to run bash. I now get a bash prompt that's in the running Docker container. And there's a variety of ways. It's actually fairly complicated. All of the options you can because it's Unix, you can have a Docker container that's running via the web, and then in another window you can attach to it and attach to the bash shell underneath. But generally, people seem to encourage you to think about these Docker containers as a single process. It's just running the one thing, and I'm not going to muck with it underneath the hood. But yes, it is a full running multi-processor OS with its whole own file system. Okay. If you guys, Luis, would you be able to help? Do you need help with getting the Docker thing running on Jetstream?
So exactly how do you know the password?
You don't?
No.
So there shouldn't be a password.
Oh, okay.
There's a private key that I send you to download.
Oh, I also didn't actually give you one.
Okay. Well, so that's a separate problem.
So, but just as a man page, so it's SSH and
SSH -I and the .pem file, and then Titus at. Yeah. Okay. Okay. So the next question that I want to address is, how do you build your own Docker image? You know, we have this super cool, like I can download the Jupyter one, I can download the RStudio web one, but I want my own tools, with my own configuration in my own Docker image. And here I've been using the words more carefully than I often do. So I'll just say, I've been talking about images and containers. An image is essentially the static operating system installed everything in one block. And you can take that image and you can run multiple containers from it. So every time we run Jupyter Notebook or RStudio Web, we get a whole new blank running container because it's taking the image, which is called Jupyter/Notebook or Rocker/Tidyverse, making a running copy of it, of that image. And then whatever you modify in here doesn't get folded back into this. Okay? So Luis likes to make fun of me for comments like this, but for those of you that are used to the days of physical media, where you had a CD or a DVD, right? And you would take this physical object, not just a USB stick, but like something that you couldn't actually write to, and you'd put it into your computer and you'd boot a new operating system off of that. That's what we're doing here. This is like a pre-installed DVD of your software. And of course, this not being the age of physical media, you can make as many copies of that as you want very, very quickly. And so that's what it's doing. And something else that I don't know that well enough to talk with expertise about it, but it doesn't actually make a copy of this image. What it does is it adds layers on top of it. So you're not like, if you're running 10 copies of Jupyter Notebook, it's not making 10 copies of Jupyter Notebook. It's making one set of additions for every change you make, every file you save, and so on and so forth. So it's storing what in computer science terminology we would say is sort of a delta or a diff with the underlying image. There are ways of taking this container and baking it back into a named image, but it's generally recommended not to do that. And the reason is for reasons of reproducibility and simplicity. The way you build images is not by starting up a computer and configuring it manually and then saving it. Instead, what you do is you write a recipe and you use the recipe to construct the image. And there's a couple reasons for this. One reason is that for those of you who are fans of scientific repeatability, it's very hard to actually track what you're typing in at a prompt interactively. It's even harder if you're doing it via like a spreadsheet program or a GUI or something, right? But it's still hard to do if you're typing it in prompt. So instead, what you do is you back away and you put it in a recipe, say, these are all the things that I would type to configure my computer, but I'm gonna put them in a shell script in effect called a Docker file, and then I'm gonna produce the image from that. One nice feature of this is this can be versioned because it's a simple text file and it's small. So now that can go on GitHub or in a Git repository or something, and you can pass that to other people. Another nice thing is that when you need to debug this, when you need to build it and you get it wrong, you can just edit the text file and rerun it, which is quite a convenience. Questions at this? No? No? Everybody's good?
Are you gonna show us?
I'm good. We're gonna do it. We're gonna make our own image. Yeah.
I guess I'll ask this.
Yeah.
So when you, and maybe this will become obvious if we're making our own Docker file now, when you're talking about like the commands you need to run to set everything up, does that include like actually like calls to install your particular library?
It does, yeah.
Okay.
So it's very explicit. It's do this, then do this, then do this. And if you forget to do something, well, you gotta redo the whole thing. So, okay. So we're gonna do this, and here's why I highly recommend copying and pasting, because there's enough commands here that you know, you're gonna get it wrong. And I do something weird. So this is doing something weird here. So rather than have you open up a text editor and edit a file, we're just using something that's copy pastable that will create a file, and I'll explain that. But all that's really important for you to know for right now is that this block of commands creates a file called Docker file containing everything from here to here if you paste it into a shell prompt. If you're interested in reading more about what this is, it's called a here doc, and you can Google HERE-doc. And basically what it's saying is put in the Docker file everything I paste or type until I see the word EOF at the beginning of a line. And the reason I do it this way is a significant point of failure in some of the courses and workshops that I teach is just open a text editor and add stuff and save it. And then, you know, you end up with half the class in chaos because they're either they have the wrong text editor, they're not used to Nano or Pico or whatever it is we're using, or they end up using something that puts binary characters in, and then disaster. So what we're going to do, we're going to make a directory. We're going to call it my hello. The -p says if the directory already exists, don't complain, and if it's multiple directories, make multiple directories. You could ignore it if you don't put it in. And then cd my hello changes us into that directory, and then we create this Docker file. And I'll go through what's in the Docker file in a second. But you can go to the command line and run this. And now you should see in this directory, there's this file, Docker file, and if you look at that file, it's a text file that has the following in it. And most of these look suspiciously like command line commands, right? There's copy, well, ignore copy. There's run, chmod, whatever. There's run, group add, and user add. And there's, and those are the two shell commands. There's this from, which I'll explain in a second. User root means run the next set of commands until the next user command as the user root. Copy says, this is a little bit tricky. Copy says, copy from my local directory, this file, into the image directory user local bin. So this is my laptop, and this is the image that we're constructing, user local bin. Run says run on the image or on the container that we're using to build the image, chmod +x this. So we're taking this file hello.sh, copying it to user local bin and making it executable so that we can run it. We're running this group add, which just creates a user Ubuntu. We're switching to that user that we've just added. And then we're specifying that when you run this Docker container without any other arguments, it should run hello.sh. Okay. Now, where is hello.sh coming from? It's not in our current directory. It's because we haven't written it yet. So that's what we're going to do next. The last thing I want to point out is from Ubuntu 14.04. Every Docker container, every Docker image approximately, this is sort of one of those 99% true statements, starts from some other Docker image. This is saying start from a blank installation of the Ubuntu operating system version 14.04. If you wanted to start from the Jupyter Notebook thing, from the Jupyter Notebook image, you could put from Jupyter/notebook. And then it would build all of these commands on top of the Jupyter Notebook image. So this is a way of sort of composing images so that you can say, I have a base image that has all my different software installed, but in this case I want it configured this way, and in this case I want it configured this way. So that can be useful if you have sort of a lot of software you use that has the same prerequisites, but you want different commands to run or different data to be preloaded. You can do it this way. One last comment: when you build this image, all of this is going to be in essentially one blob, in a blob. Just to say, when you copy files in, the file gets added to that image. It becomes a self-enclosed one-stop shop image. That's sort of approximately right. It actually becomes a bunch of layers, but the layers when combined are this one thing. So the reason I'm saying that is I work in biology. We have a lot of sequence data, maybe 10, 100 gigabytes of sequence data. Don't copy your sequence data into your image and then try to distribute it, because then what you're doing is you're bundling the programs and 100 gigabytes of data in one blob that you're trying to communicate to people. So this is sort of the goal here is to sort of separate what you're running from what you're running it on, and how you do that is a different problem. That's where the workflow systems come in terms of managing your data, that sort of thing. Does that make some hand wavy sense? Okay. It all goes in one place. Don't copy big files in. That's that you don't need. I mean, if it's a program, well, you have to have the program fully installed. And there's a lot of tricks and techniques and tips on how to build these things that I reference in the documentation. Okay, so now we're going to create this file hello.sh. I don't know how many of you have run across shell scripts before, but basically what we're doing here is writing the canonical hello world in bash, in a bash shell script. Okay, so here's the cool thing. It doesn't matter what, right? You can do this with anything. This is just a very small example. So you could put your own software, your own script, somebody else's scripts on here in exactly the same way. This is just so that it's sort of small enough to easily comprehend. So we'll run this. And now in the current directory, we have two files. We have the Docker file. The Docker file is the recipe. And we have hello.sh, which is a file that the recipe needs to have in order to build the image. And this is what you would put in version control. This is what you'd put on GitHub or something if you wanted to communicate your recipe to other people. And now we run the command docker build -t my hello and dot. And what this does, I'll go back to the command in a second, but it basically says build it, call the image my hello, give it the tag my hello, and build it from the current directory. That's what the dot means. And you can see, if you look, it tells you everything that it's doing. So it's saying, okay, step 5 out of 7, run group add. Step 6 out of 7, switch to user Ubuntu. Step 7 of 7, set the command that's going to be run. Now, this is one of these things where I just want to pause and point out how cool this is. I have a Mac. Linux is not actually installed on this hard drive as its own operating system. These are all being run inside an Ubuntu Linux computer running in a container on my Mac. So I don't have to install Linux anymore. I can just run Docker containers for whatever I want. In this case, I'm building all this. So the commands that you would put in the Docker file are the commands that would be run to install your software on an Ubuntu 14.04 machine. If you're familiar with Debian or Ubuntu, it would be the apt-get install, apt-get update, wget this file, bash this file, whatever. It'd be the Linux commands. So for those of you who are increasingly reluctant Applophiles like me, I own every piece of hardware that Apple has ever produced, except for an Apple Watch, because some things are too ridiculous. I actually can run the operating system that I do all my work on my beautiful Mac hardware. Okay, so no offense if somebody in the room has an Apple Watch. I'd be interested in knowing why it's useful, because I really was like, I don't know what I would use it for. I have a phone, I have an iPad, I have a laptop, I have a pencil. Like, all of them can tell time. Anyway, so okay. So now we built this, and now we can do docker run -it my hello. And I think that should work. And it says hello world. So that was a long path to a hello world, right? But it's a general thing, right? It's here's the recipe, here's the recipe for building that hello world, and you can actually take this and modify it and add your own programs that you wanna add. And if you go back to the if you go back to this and you go all the way to the top of the tutorial materials, this is today's hour and a half is a shortened version of a 2-day Docker workshop, and actually shows some more real Dockerfile examples in there that actually like install the mega-hit metagenome assembler and install some of our software in a Docker container and then push it, which I'll explain in a second. So I think I can say it is actually that simple in my experience to build your own Docker container. I've done it a few times. Okay. So if you're interested in best practices on writing Docker files, there's a page that's hosted on docker.com that gives you a bunch of very confusing advice. Just to skip all the way to the bottom, I want to say that if you're interested in actually doing this on some of your own software and you just want a friendly group of people to hang out with while doing it, we run these meet and analyze data sessions on Wednesdays over on the health sciences side of campus, where you can just come hang out, and Luis is there more often than me, admittedly, but Luis and I and others from my lab and other computationally friendly people can either help you solve your problems or commiserate that your problems are unsolvable, depending on which way you go. But we're happy to like Luis has a tremendous depth of knowledge and an even deeper depth of opinions about how to properly do things with Docker, and he would be happy to share any subset of that with you at a moment's notice, more or less. So please feel free, if you're actually interested in doing this, come by and feel free to come by and chat. And we're happy to meet if that time, if Wednesdays 3 to 5 doesn't work, we're happy to set up other times. But okay, so 2 more quick things before I talk about 1 or 2 general things. So there's a listing of some commands. These are the ones that I've mostly used. There's Docker run, which says take an image, turn it into a running container. There's Docker build, which we've used to just construct an image from a Docker file. And there's Docker pull, which we used a couple times at the very top, to take an image that somebody else produced and post it publicly and bring it to the laptop. Some ones that I've mentioned some of along the way. Docker PS lists the running containers. Docker rm-f does what it sounds like. It kills the container and removes the working image. So if you just want to say, I don't want this anymore, I don't want anything left of this, Docker rm-f will get rid of it. Docker RMI, if you've downloaded a 10 gigabyte image by mistake, you just want to get rid of it, that will remove your image. And then Docker push is something we haven't used yet because it requires an extra account, but you can actually build an image and push it to a site that will host it for you publicly so that other people can download it. And there's ways to build, if you were interested in having private Docker images because you had, for example, licensed software that you couldn't distribute publicly, there are ways to have a local version of this that lets you share Docker images among people in your group. There's also public sites that let you do that. Quay.io, which I'll reference in a second. You can buy a private hosting plan, and they will host private Docker images for you that you have to have a username and password to get at. So if you have a group that's doing pre-release software of some kind and you want to build a Docker image so people can run it and test it in your group, you can host it on stuff like Quay.io as well. That just makes it so that you know, what you're running and what you're running and what you're running are all the same thing, which is one of the points of Docker, right? So that when it doesn't work, at least you have an objective statement that doesn't work. Then you can figure out if it was the fault of the person who wrote the software or the person who built the Docker container. Fun new blame game. So just to sort of go back to that a little bit, I'll just say, so the sort of terminology is you have a Docker file that you post, for example, to GitHub. Rather than building it yourself, what we recommend, what everybody I think recommends, is you can point Docker, the hub.docker.com or quay.io at your GitHub repository and say, every time I update this Docker file, build me a new image. And quay.io will actually do that for you, right? So it'll say, oh, you just updated your recipe. Let me rebuild that image for you. And it'll tag the image. We haven't really talked about tags, but it's the stuff after the colon. So Ubuntu colon 14.04. The image name is Ubuntu. The tag that refers to a specific version of the image is the 14.04. So Quay will update your image name with whatever release is on GitHub. So you could have sort of a piece of software that you periodically update, and every time you make a new release, an image is automatically built and hosted at Quay.io. And then anybody, if it's a public image, can go download via pull that image. I don't know how many words I'm using there that people don't understand, so please feel free to ask questions. But basically, like, with an only mildly frustrating amount of upfront work, you can take a GitHub, you can go with a standard GitHub workflow, which I'm happy to talk about, and have images built automatically from what you put in your GitHub repo every time you make a new release on GitHub. And so we're starting to think about how to do that more now, or at least I am, as of like, it's one of the reasons I run workshops, is because now it makes me think about these things. So I think we're going to do this for some of our software. There's no reason you have to use these public sites or even private mode. You can have the images locally on your laptop if they're just things you're using. But if you're sharing between multiple labs, it's good to have a common place so that you're all using the same thing. Okay. So I have two more things I want to quickly talk about, but I can take questions right now if there are any on what I just said. No? Okay. So there are a lot of people that are interested in using Docker for workflows. So what I mean by workflows is, at least in my field, which is genomics and computational biology and bioinformatics, we tend to need to run about 8 different programs in sequence on a set of data, right? Like, take our raw sequencing data, trim it, do some quality evaluation, trim it some more, run an assembler, run an annotator, run a differential expression analysis package, make a figure, right? And that's a whole workflow, and it usually involves maybe 5 or 6 programs or 8 programs. Some of them are hard to install, and some of them are annoying to install, and some of them only run on Linux of this version and that version. And so how do you connect a bunch of Docker containers together? And that is that's something I'm not expert at, and it's well outside the scope of what I can talk about in the next 5 minutes. But I think the frustrating thing is everybody wants to do this, and so everybody has developed their own way of doing this. So how many of you have seen the XKCD standards comic? So how standards proliferate? There are 14 competing standards. 14, that's ridiculous. We need one universal standard. Now there are 15 competing standards. So this is what's happening with Docker and workflows. And so I'm going to give you an only slightly opinionated, but almost certainly entirely correct perspective on all of this, which is I heard good things about two workflow systems in particular. One is Dockstore and one is Nextflow.io. I have personal recommendations from people that have actually used them, which counts for something, that weren't the authors of them. It's also important. And these are things you can look at. Dockstore, I just want to show you briefly. Dockstore has some nice, is something that the Cancer Genome Collaboratory is using. They're already using it to analyze hundreds of thousands of cancer genomes. And it's essentially as simple as, give me a file that tells me where my source data is, tell me where you want to put the output data, and run these packages in a row. Connect them like building blocks between them. To do that, you have to not only have a Docker container, but you have to have something that describes what the Docker container, how to run the Docker container. And so that's the little bit of extra sauce. There's something called a common workflow language description that describes what's in the Docker container and how to run it. All I can say is this is an entirely open source and community supported platform that has enough funding to keep going for a while. And they seem to be doing things the right way. So I'd recommend looking at something like Dockstore if you're interested in providing workflow components that you and others can use on your own data. We're interested in doing this for metagenomics. We have some funding to do this for environmental metagenomics. So we're gonna start doing this in the next couple of months. So please feel free to stop by and chat. Luis will spend the time telling you why what we're doing is imperfect, and I will spend the time telling you why what we're doing works well enough. No, it's a very valuable very valuable service that Luis provides. So the other thing that I want to talk about is using Docker on our local campus HPCs. So Docker does not, so Docker is inherently a security problem. And that's because it was originally designed for Silicon Valley companies that wanted to run lots of different like web servers and databases running behind the web servers and stuff. And so they assume that you essentially own the machines that you're running it on, so you don't need to worry about systems administrator privileges. So it's not designed, so it's designed with what's called, it has within it, I believe, a privilege escalation security hole. So if you can run Docker, so when you install Docker, it has to run as the systems administrator, obviously, because it's running a lot of stuff like right within your operating system, and you can use that to take over the computer. This is not really a concern for those of you with laptops where you have systems administrator on your laptops because you already have systems administrator. It's not a concern in the cloud because in the cloud, Amazon and so on have other layers of protection that you can't actually take over those machines other than what they've already given you. But it is a problem on local HPCs like Farm and Cabernet because they don't want, very wisely, they don't want to give all of you systems administrator privileges. So there's a Docker compatible set of software called Singularity that needs to be installed, but that doesn't need systems administrator privileges to run. It needs systems administrator privileges to install, but not run. It's running on a bunch of HPCs off campus. It's not running on campus HPCs yet. That's probably partly because they don't have any requests. They don't have many requests to install it. So if you have a friendly local HPC, you could drop them a note saying you'd be interested in trying out Singularity. There's a bunch of national labs and stuff that are running it. So you know, maybe it's secure. I wouldn't suggest phrasing it like that. And you can do a lot of the things that we talked about here with Singularity. It's Docker compatible, so you can import Docker images. And so that might be a way forward for people like who need it on their local clusters. Yeah. So I think with 5 minutes to go, I'll just say that's all I have to say. I'm happy to take questions. I'm happy to chat now or at any later time about how you want to use Docker or anything else. And if you're interested at all in discussing this kind of stuff, we have these sort of open office hours on a roughly weekly basis, and we're happy to sit there quietly and work while you work, and we're also happy to chat with you about what you're doing and see if there are any problems that we can help fix. So. Any questions at this point? Yeah.
So for reproducible research, once you create an image, all the package versions that are frozen.
Yes.
Unless you go in and.
That's right.
Okay.
So just for the benefit of the camera. So for reproducibility, once you have frozen and once you've built an image, that image is now static, and that's your reproducible thing. So there's a lot more to be said, and there's actually a Nature news article coming out in the next couple of weeks on this that goes more into depth about this. But you can communicate that image to other people who want to repeat what you've done, sort of at a almost byte for byte level. There's a couple caveats that don't really matter, having to do with there are some programs that if you run them on slightly different hardware, right, it doesn't actually emulate the hardware. So there's some situations with floating point and so on where you might get different results from the Docker image because it is running everything on the actual processor. It's not emulating the processor machine. But yes, it is repeatable. My recommendation generally is to rely on two things. One is to have an image that you hang around. It's usually quite big, right? This image can be a gigabyte or larger, depending on what software you're installing. But also keep the Docker file around. And then periodically, if you really care, there's a lot of sort of discussion that goes into this, but if you really care, you can try rebuilding the image and see if you get the same results with your newer version of the software, the older version of the software. And that's good practice because for all sorts of reasons. But at the worst, you can always go back to this image. The one caveat about that statement is if Docker changes things about how they store, newer versions of the Docker software may not run old images always. So, and I've heard people tell me that that's sort of a 2-year life cycle, where using images that are like 2 years old is maybe not, may or may not work. But that's totally dependent on things that are outside of your control, which I think is worth just keeping in mind. Yeah.
Comment to you, Bill Broadley is watching.
Oh, cool.
He just said that any farm, HPC1 or Peloton, I'm saying it wrong.
Peloton?
Yeah. They're interested in Singularity. Email help@cse.ucdavis.edu.
Oh, cool.
They're planning to evaluate it this summer.
Cool. So just to say that more loudly, so if you email Bill Bradley or the clusters at help@cse.ucdavis.edu, they're interested in evaluating Singularity this summer. And I believe the Genome Center cluster has said similar things. So they're probably looking for somebody who's going to try doing things with it. And I'm sure my lab will also do that. But your use cases will be better represented if you spend half an hour trying it out. So drop them a note if you're interested. All right. Cool. I gather this has been recorded. So the YouTube link should have been in the announcement to the data science announce that was sent around. These materials will remain up, and I'm more than happy to interact around these questions at any time. So thanks.
Yeah,